Good evening, everyone. So, in our last class, we have discussed about comparators. Okay, how many types of comparators are there, and what is the construction, and how many number of elements are used in the comparators principle. Okay, so while coming to the comparator, it is a device which is used to compare two variables or more than two variables and produce the output as either the first variable is equal to the second variable, or it may be greater than the second variable, or it may be less than the second variable. So in this way the comparators will provide the comparison between the variables. So to compare, must and should device having more than one variable. With one variable, comparison is not possible at all the time. So comparator would require two variables or more than two variables to provide the comparison. So after comparison, it will provide either the first variable is greater than, or it may be is equal, or it may be less than the second variable. So in our last class already we have discussed about 2-bit comparator. There we compare only single bits, and 4-bit comparator is also there. 4-bit means A having A0, A1, A2, A3, and B having B0, B1, B2, B3. Okay, so here the bit A0 is compared with A1 and B0 is compared with B1, like that. So if it is greater than or less than that of our given number, and it will produce the result. Okay, and in our last class we are also discussed about that which ICs are used in TTL series, okay, 7000 series, and which ICs are used for multiplexers and which ICs are used for decoders. Okay, so 1000 series, 72,000 series, and 4000 series, and 8000 series will able to produce the multiplexers, demultiplexers, decoders as well as encoders. Okay, and all series will produce all possible combinations. So while coming to the TTLs, it may be either open collector, or it may be NAND gate, NOR gate, latch, high output parameter. So like that, each and every combination will provide with the help of our series. Okay, and see here, while coming to today's topic, now we are discussed about sequential logic circuits. So till now we read about combinational logic circuits. So what is the logic involved in combinational logic circuit? So combinational means, already I told you, present output depends only on the present input. It's not depends on the history of previous inputs or outputs. So that is the theme involved in the combinational logic circuits. Okay, that is the theme involved in combinational logic circuits. The present output depends only on the present input. It not depends on the history of previous inputs. Okay, but now we are going to discuss about sequential logic circuit. So how many number of combinational logic circuits we are discussed, and what are the examples? So already we have discussed about adders. It may be half adder, or it may be full adder, or it may be parallel adder, and or it may be a serial adder, and or it may be 2's complement adder subtractor, whether it may be multiplexer and also demultiplexer, and decoders are there, and encoders are there, comparators. All these are the examples of our combinational logic circuit, especially gates, basic gates, universal gates, as well as our special gates, exclusive OR gate as well as exclusive NOR gate. Okay, so in this way it is used, okay, to provide the operation. The present output depends only on the present input. And while coming to the today's topic, sequential logic circuits, and what the main differences between combinational logic circuit and sequential logic circuits, and basic elements in sequential logic circuits, those are NAND latch and NOR latch, and also what is the necessity or need of clock, and also explaining different clocking methods. So now we are going to discuss about these topics. So while coming to the sequential logic circuit, so before opening the slide 1C. In combinational logic circuits, present outputs depends only on the present inputs. But here, present output depends on the present inputs and also the previous outputs. Is it clear? In sequential logic circuits, present output depends upon the present inputs, also on the previous output. Is it clear? But in combinational logic circuits, present output depends only on the present inputs. But here, present output depends on the present input and the history of previous output. So this is the principle involved in the sequential logic circuits. Is it clear? Okay, see here now. So this is the block diagram of sequential logic circuit. So here see the combinational logic circuit plus memory elements made the sequential logic circuit. So in combinational logic circuits, present output depends only on the present input. But here in the sequential logic circuits, present output must be stored in the memory elements and it must be produce the present output. So here the present output depends on the present input as well as the previous stage output. So to store the previous stage output, here one storage element or memory element is used. Okay, in combinational logic circuits, present output depends only on the present input, but here in the sequential logic circuit, present output depends on the present inputs as well as the previous output. So each and every time there is a need of storing the previous stage output. So where we store the previous stage output? In the memory element, so that it must and should requires one memory element. Is it clear? This is about the block diagram of sequential logic circuits. What are the elements in the sequential logic circuit? Combinational logic circuit is there and memory element is also there. Okay, with help of combinational logic circuits and memory element, sequential circuit must be made. But in combinational logic circuit, present output depends only on the present inputs. But now it is sequential logic circuit. Here the present output depends on the present stage inputs as well as the previous stage outputs. Is it clear? So this is about what? Block diagram of sequential logic circuits. Okay, see here in slide briefly explain. So what is the use of memory element here? It's capable of storing binary information, and the information stored in these memory elements at any given time defines the state of sequential circuit. So whatever the information, previous stage output, that is stored in the memory element is in the form of binary. It means sequential logic circuits also work with only binary, not octal, not hexadecimal, not decimal numbers. Sequential elements also works or also process only the binary bits. So in sequential logic circuits, whatever the memory element we are using is used to store the binary bits, and the information that stored in the memory elements will defines the state of the sequential circuits. The output in sequential circuit are a function not only of the external input but also the present state of the memory elements. Is it clear? And see here, while coming to the classification, sequential logic circuits are classified into two types. How many types are there? Basically, the sequential logic circuits are classified into two types: synchronous sequential logic circuits and asynchronous sequential logic circuits. How can we classify the sequential logic circuit? Sequential logic circuits are classified into two types: What are the two types? Synchronous as well as asynchronous. And see here, while coming to the classification, and in asynchronous, okay, in asynchronous, which elements are used? Flip-flops used. In synchronous, also flip-flops used. But what is the difference between asynchronous and synchronous? In asynchronous, all the flip-flops are triggered at different instants by the different clock pulses. Okay, asynchronous means each and every flip-flop, asynchronous circuits, each and every flip-flop triggered with different clock pulse. But in synchronous, all the flip-flops will be triggered by the same clock pulse at the same time. Okay, all flip-flops must be triggered by the same clock pulse simultaneously at the same time. That's why these called synchronous. Once see the diagram. For example, in asynchronous, two flip-flops are there. Two flip-flops are clocked individually. Different clock pulses are applied. But in synchronous, same clock pulse is applied to flip-flop 1 and also flip-flop 2. This is about what? Synchronous and asynchronous circuits clocking. Is it clear? In asynchronous, all the flip-flops in the circuits are triggered at different instants by the different clock sources. But in synchronous, all the flip-flops are triggered by the same clock pulse at the same time. And see here, while coming to the asynchronous, these circuits are slow because of, in asynchronous, first stage output acts as a clock pulse for the next stage. I told you now, all clock pulses are clocked with different clock pulses. So from where we are getting the different clock pulses? Output of one flip-flop acts as a clock pulse for the next flip-flop, so that second stage flip-flop waits until the first stage output will be occurred. But in synchronous, there is no delay. Why? Because the clock pulse must be applied to all the flip-flops at the same time. Okay, but in asynchronous, output of previous stage acts as a clock pulse for the input of next stage. But in synchronous, no time is there. Clock pulse is same clock pulse is applied to all the flip-flops. And here, while coming to the asynchronous, the circuits are very, very slow. But in synchronous, the circuits are fast. And in asynchronous, cumulative propagation delay is the major disadvantage. Already I said that. Why this delay occur? Because of clock pulse must be provided from the output of previous stage to the next stage. So that must and should the delays will be provided. In synchronous, no delay. If first stage output is coming or not coming also, second stage will be activated. Okay, instability is more. Okay, instability is more. Means the without depends upon the simultaneous clock pulse. It may be unstable, so less used. But synchronous is more stable and it is commonly used. Why? Because all the flip-flops are triggered at the same time with same clock pulse, so the output is stably produced. Because of no delays are there, the circuit also becomes very, very speed. And see here, while coming to the other difference, in our last class we are discussed about what? Combinational logic circuit. So now we have discussed about what? Sequential logic circuit. Already I told you the definition. In combinational logic circuits, present output depends only on the present input. But in sequential logic circuits, present output not only depends on the present input but also depends on the previous stage outputs. Is it clear? In combinational circuits, present output depends only on the present inputs, but in sequential logic circuits, present output depends on the present inputs but also on the previous stage outputs. And while coming to the combinational logic circuits, they do not require the memory elements. They do not require memory elements. Why? Because there is no need of storing previous stage outputs. Produce the present outputs. Present input is enough. No need to storing the previous stage outputs. Okay. But here in the sequential logic circuits, present output depends on the previous stage outputs, so that there is a need of compulsory storing the previous stage output. So to store the previous stage output, memory elements are required. Okay. And while coming to the next one, the basic building blocks of combinational logic circuits are logic gates only. What are the basic building blocks? How can we develop the combinational logic circuits? Logic gates. While coming to the example, half adder is there. In half adder, how the half adder will be constructed? With help of gates only now. To express the sum function, exclusive OR gate is used, and to develop the carry function, AND gate is used. Likewise, full adder also. It requires 2 half adders, means 2 exclusive OR gates, 2 AND gates, and 1 OR gate. Same, a parallel adder also requires 3 n number of full adders, inside it containing gates only. At the same time, already in our last class and previous class, we are seeing about multiplexer, demultiplexer, comparator, converters, etc. Everything must be made with gates only. Whether it may be AND gate, or it may be NOT gate, or it may be AND gates, whatever it may be, all the circuits, all the combinational logic circuit, so basic building blocks are gates only. Of course, either it may be the basic, or it may be the special, or it may be the universal. All combinational logic circuits are designed with the help of gates only. And see here the combinational logic circuits are faster than the sequential logic circuits. Why? Because present output depends only on the present input. Okay, is it clear? But in sequential logic circuits, present output depends on the previous stage output also, so that first it is stored and then it is transferred to the next stage. Because of this, the delay will be provided automatically. The operation will become slow. Is it clear? These are the main differences between combinational logic circuit and sequential logic circuits. Okay, and see here, so this is the basic flip-flop or latch. So first of all, what is meant by flip-flop? What is meant by flip-flop or latch? So here the flip-flop or latch means, see here, every flip-flop. So here flip-flop is a bistable multi-vibrator. So flip-flop is called what? It is a bistable multi-vibrator. Why it is called bistable multi-vibrator? Why it is called bistable multi-vibrator means it is used to produce the vibrations. Which kind of vibrations? Stable vibrations. And how many number of stable vibrations it will produce? By means how much? 2. So flip-flop is a bistable multi-vibrator. It able to produce 2 stable states only. How many number of states will be produced by the flip-flop? 2 stable states. What are the 2 stable states? How many number of stable states are used? One is flip and other one is flop. So here flip indicates set and flop indicates reset. And here flip indicates high level output and flop indicates low level. So flip means what? High level. Flop means low. Flip is called set and flop is called reset. So the name flip-flop is derived from its output. So what is meant by a flip-flop? Or defined flip-flop means what? It is a bistable multivibrator. It is used to produce two stable states. What are the two stable states? One is flip, other is flop. One is set. Flip is called set condition. Flop is called reset condition. Flip is indicated with binary 1 and flop is indicated with binary 0. Flip is indicated in terms of high level signal if it is a signal. Flop is indicated with low level signal. Okay, so that's why the name is arrived flip flop. Okay, flip means high, flop means low. And see here, the basic elements of flip flops are called NAND latch as well as NAR latch. Means the flip flop is made with either the NAND gates or the NOR gates. And how can we design? Means the output of one flip flop is connected back to the input of next flip flop. In this NAND latch, which gates are used? Only NAND gates are used. And in NAND latch, how the connection is established? The present output of one NAND gate is connected to the input of next one, and the output of second NAND is connected to the output of first one. Is it clear? Output of first NAND gate is connected to the one of the input of second NAND gate, and output of second is connected to the one of the input of first gate. And see here two elements, two inputs are there. These are directly connected to the two NAND gates. Two inputs are there, means here the NAND gate having two inputs, one is directly connected, other is came from the output of second one. Is it clear? Okay, and see here, this is the truth table. So in truth table what we observe? So if the inputs are 0 and 0, if the inputs are 0 and 0, see here, if it is 0, what is the output of NAND gate? 1. If it is 0, any of the input is 0, output is high. But how the outputs are represented in NAND latch? One is Q, other is Q bar. Means both outputs of the flip-flops are complemented to each other. How the outputs are made? Both outputs are complemented to each other. Both outputs are complemented to each other. So, but now after application of S is equal to 0 and R is equal to 0, the output, both output becomes 1, 1. But it will violate the principle of outputs. In flip-flop, the outputs are always complemented to each other. If cause of application of inputs applied at the NAND latch, if it violates the original principle of outputs, then those state outputs are eliminated, and that stage is called unpredictable states. What is the name of that state? Unpredictable states. Is it clear? Both the inputs are 0, then the state is called unpredictable state. Okay, see the truth table. And while coming to the next one, if R is equal to 0, S is equal to 1. R is equal to 0, S is equal to 1. See here, if any of the input is 0, the output is what? 1. So now you see, this 1 is connected back to here. Both are high, then here we are getting 0. So now see, if S is equal to 0, we are getting, if S is equal to 1, original output or normal output Q is equal to 1. If S is equal to 1, Q is equal to 1. So this condition or this state of the flip-flop is called set state. What is the name of this state? Set state. Okay. And while coming to the second stage, if R is equal to 1, S is equal to 0, if any of the input is 0, what we are getting here? For the NAND gates, 1. Now this one is connected here. If both are high, again it becomes 0. That means if reset is 1, Q bar is 1 and Q is 0. Reset means no output is there. So Q is considered as original output or normal output. So Q bar is complement of original. If set is 1, Q is 1, that condition is called set condition. If reset is 1, the output is not produced, that condition is called reset condition. Okay. If S is equal to 1, what is the name of the stage? Set condition. If R is equal to 1, what is the name of the stage? That is called reset. If both are high, any of the input is high, then what we are getting here? Both are 0. But again it will violate the original principle of outputs. What is the law of original outputs? Outputs are always complemented to each other. How the output? Outputs are always complemented to each other. Outputs are always complemented to each other. But by application of both inputs high or both inputs low, it will violate the principle of original inputs. So that by application of 0 and 0, the stage is called unpredictable stage. And by application of 1 and 1, it is called no change or held condition state. But if S is equal to 1, the normal output Q is equal to produced 1. This state is called set condition. If S is equal to 0, R is equal to 1, then Q original output is 0 and Q bar is 1. So this condition is called reset condition. Is it clear? So this is about what? NAND latch. In the same way, NOR latch is there, but here NAND gates are placed with help of NOR gates, but as it is the operation is same. If both inputs are 0, the output will not be changed, means it will violate the original rule of output. The rule of outputs are both outputs are complemented to each other. Okay, but after application of inputs are same, it will violate the law. And see here, next, if R is equal to 1, again Q is equal to 0 and Q bar is equal to 1 we are getting. So this state is called reset stage. If S is equal to 1, Q is equal to 1 we are getting, that stage is called set condition. And finally, if both inputs are high, no output will be produced. That stage is called unpredictable state. Both the operations of NAR and NOR are same. Okay. Next, see here, while coming to the next topic, necessity of clock. First of all, what is meant by clock pulse? Okay. Here, the clock pulse already in latches I explained you. See in the NAND latch, by application of Q is equal to 1 only, as both inputs are high and it will produce the outputs 0. That means what? It will wait to produce the output until and unless the first gate output is occurred. But sometimes, even though the output is not connected to the input also, it will produce the outputs, so that it leads to provide the errors. So to prevent the latches from that overspeed or delay, here we are using with clock pulse. So by application of clock pulse, if clock pulse is not there, means even though the inputs are present, the output is not produced. After receiving of output from the previous stage only, the output is produced. So that is the main theme of clock pulse. So after application of clock pulse only, the inputs will be activated and the output is produced according to their respective inputs. Okay, what is the application of clock pulse? By applying the clock pulse, the output must be produced after the application of inputs. Is it clear? So that is the main theme of clock pulse. So see here, in here clock pulse, this level is called high level. So here what is meant by clock pulse? Simply the square waveforms are called clock pulses. Square waveforms are called clock pulses. Okay. In square waveform, this rising edge. So what is meant by rising edge means? So in this way we are moving from bottom to top now. This is down and this is high. So bottom to top we are rising. So this edge is called rising edge. So 0, 1, 2, 3. In this way increasing order is there. So that's why this edge is called rising edge. So next one, see here, it must be decreased. So that's why this is called falling edge. First one is called increasing way, it is called rising edge. Next it is decreased, this is called falling edge. Okay. So here in this way this line is increased from 0 to maximum. It is also called positive going translation. Positive means it is moved from negative to positive level. So here in the falling edge it is also called negative going. Negative going means from positive side to negative it moved, so that it is called negative going edge. And how can we define the clock pulse? Means one decrement to other decrement or one increment to other increment is called clock pulse. And here this is called high level and this is called low level. Okay, this is about what? Clock pulse. Clock pulses are the square waveforms. Here the high level is means the rising edge. The positive is called high level and negative is called low level. And if positive is increased means that is called rising edge. The decrement edge is called falling edge. Is it clear? And see once check the slide. What is the need of clock? Already I told you, in the absence of clock pulse the output may not be produced accurate. The clock pulse plays very important role in the digital circuit. What is that means? It is used to open and close the digital path. Means it allow or stop the process and in general provide timing for the circuit. You can compare a clock with traffic lights. Why we can compare means they stop and allow the traffic in a timely manner. Na? If red light is means stop and green means going. So that way it will accept the inputs and control the outputs. Is it clear? So clock is generally is what? It is a square pulse. So in digital system both asynchronous and synchronous can works with what? Clock pulse. Clock pulse is applied to all the flip-flops at the same time, then that is called synchronous. If the circuit systems are worked with different pulses, then it is called asynchronous. But both circuits must and should work with clock pulse. Okay, in all synchronous and asynchronous digital circuits, the output of synchronous circuit or asynchronous is changed after the application of clock pulse only. Okay, when the clock changes from 0 to 1, this is called positive going transition. Okay, what is meant by positive going transition? If the clock is changed from 0 to 1, 0 to 1, so this is called positive going transition. If the pulse is changed from, if the clock pulse is changed from positive to negative, then this is called negative going transition. What is the name of this? Negative going transition. Is it clear? And say here depends upon the positive going level and negative going level. flip-flops are classified into two types. What are the two types? One is called level triggering, other is called edge triggering. Okay, once see the clock pulse. If this is the clock pulse, okay, this level is called positive level. Now this is called negative, and this is positive going, this is negative going. If the output of one circuit is changed across these levels, high level and low level, means in the clock pulse, when this level is entered, at that moment the output must be produced according to the inputs. Then the triggering is called level triggering, means after application of the clock pulse, either at a high level or at a low level, the output is changed, then the triggering is called level triggering. If the output is changed from high level to low level or low level to high level, either at increasing edge or at decreasing edge, then the triggering is called edge triggering. Then the triggering is called edge triggering. Okay, and see here, while coming to the level clocking, the output must be changed from either high or low. Already I told you, either high level or low level, like this. Either here or here, the output is changed respective of the inputs, then that is called level clocking. And see, concept of edge triggering. So edge triggering means what? The output of flip-flops or any circuit, sequential circuit, must be changed across the edge of the clock pulse, like this. Either here positive edge or here negative edge, then that is called edge triggering. So here clock triggering is of two types: positive level triggering. Okay, level triggering is of two types: positive level triggering, negative level triggering. And edge triggering is of two types: rising edge triggering as well as falling edge triggering. So finally, how many types of triggerings are there? 4 types of triggerings are there. So first one is what? Level triggering and edge triggering. And level triggering is again classified into two types. What are the two types? Positive level triggering is there, negative level triggering is there. But in edge triggering also these are two types. So what are the two types? Rising edge triggering as well as falling edge triggering. One, see the slide. So this indicate what? Level clocked flip-flops and edge triggered flip-flop difference. What is the main difference? Once check the slide. When the circuit is level clocked, the output can change while the clock is high or low. Already I told you. In level clocking, the output is changed across either high level or low level of the clock pulse. Okay. In level clocked flip-flop, the output is changed either across high level or low level. But in edge triggered flip-flop, the output is changed either the rising edge or the falling edge. Okay. Next see here, in level clocked flip-flops with level clocking, the output can change during an entire half cycle of the clock. Okay. With level clocking, the output can change during an entire half cycle of the clock. But in edge triggered, the output can change only at one instant, either at positive edge or at negative edge. And in level clocked flip-flops, flip-flops are rarely used. Means number of flip-flops we are using is reduced in level clocking. But in edge triggered, the number of flip-flops we are using is increased. Okay. This is about what? Level clocking and edge clocking. In level clocking, the output is changed across either the positive level or the negative level. The output is changed across the positive level respective of the inputs, that is called positive level triggering. If the output of the circuit is changed according to the inputs at the negative level of the clock pulse, then that is called negative level triggering. And while coming to the edge triggered flip-flop, the output of the flip-flop is changed either at the positive edge or at the negative edge of the clock pulse. If the output is changed across the positive edge of the clock pulse, then the triggering is called positive edge triggering. If the output is changed across the negative edge of the flip-flop, then that is called negative edge triggering. And with level clocking, the output can change during an entire half cycle, but in edge triggering, the output can change only at one instant during the clock cycle. And while coming to the level flip-clocked, the flip-flops are rarely used, but in edge triggered, the flip-flops are widely used. And see here, and what is meant by flip-flop? So flip-flop is what? 1-bit memory element. Flip-flop is what? Simply latches are also called flip-flops. After the application of set input only, the output is produced now. So that means what? Each and every latch having the capacity of storing only 1 bit. So here the flip-flop is a 1-bit memory element. And while coming to the types of flip-flops, flip-flops are of 4 types. So many flip-flops are there. So basic flip-flops are SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. How many basic flip-flops are there? 4. SR is there, JK is there, D is there, T is there. But in addition to this, master slave flip-flop is also there. Here SR flip-flop is called set reset flip-flop, JK flip-flop is there, and D flip-flop means data flip-flop, and T flip-flop is called toggle flip-flop. T flip-flop is called toggle flip-flop. Okay. And see here, while coming to the summary, today we have discussed about what? Sequential logic circuit, and what are the types of different sequential logic circuits, and differences between sequential logic circuit and combinational logic circuit, and also the definition of flip-flop. So here coming to the multiple choice questions. First read one question. The output of sequential logic circuit depends on present input, previous output, A, B, none. What is your answer? My answer is A and B. Why? Because sequential logic circuit depends on present input as well as previous output also. Okay, correct. Next, in a RS NAND latch, if R is equal to 0, S is equal to 1, the output Q. Already I told you, if S is 1 means Q is 1. If S is 0, Q is 0. Simple. It is very easy. If S is 1, what we are getting? Q is 1. 1 is only the answer. It's clear. Okay. Next. The unpredictable state occurs in NAR latch when R is equal to and S is equal to. In NAR latch, when we are getting unpredictable state, when R is equal to 1 and S is equal to 1, means my answer is 1 and 1. 1 second. My answer is what? 1 and 1. See, yeah, it is correct. And while coming to the previous questions, 5 marks questions are explained the operation of NAND latch and NAR latch, and the differences between synchronous and asynchronous, and difference between the combinational and sequential. These are 5 marks questions. Okay, explain NAND latch and NAR latch, and difference between the synchronous and asynchronous, combinational and sequential. While coming to the 1 mark, state latch, state flip-flop. What is the need of flip-flop? And classify the triggerings, state edge triggering, state level triggering, classify the triggerings. So all these are 3 marks as well as 1 mark questions. Okay, so every topic has its own priority. So you have to prepare all topics. Okay, there is a need of preparing all topics. So now I would like to conclude the class. Okay.